Radio, we're continuing on with our new area on non-right angle trigonometry, and we're up to the sine rule now. So in yellow is what is the sine rule, and remember you're also given it in your formula booklet. So the formulas on page 2 of your unit booklet, I just remind you what formulas you get given in the exam. So you get given the area formula, the sine rule, and you get given the cosine rule. So now let's try to prove what this sine rule is here. So again, you probably don't really need to do a proof in your exams at all, but it's just good to know where these formulas come from. Plus, it's also good practice of right angle trigonometry when we do these proofs, like SOHCAHTOA and Pythagoras. So kind of similar to how we did the area formula proof. There are many ways to prove this rule, but this is just one of them below. So we've got the three angles, A, B, and C. So note that the side opposite angle C, what do we label it? We label it lowercase c. Oops. The opposite of angle B, as you can see, opposite of angle B is lowercase b, and the opposite of angle A is labeled lowercase a. Alright, so we can, first of all, the instruction is divide this non-right angle triangle, divide it into two triangles by drawing a dotted vertical line through the middle. So we've drawn a dotted vertical line through the middle, which we'll label H, because it says label that dotted line H for height. Remember the height, it breaks this non-right angle triangle into two right angle triangles. So you might want to label in a little right angle here. So we've divided it into two different right angle triangles, and we've labeled the height H. Now we're going to use SOHCAHTOA and right angle trigonometry to complete the formulas below for these two right angle triangles. So if you look at the sine of A, remember sine of A is opposite over hypotenuse. So what is the opposite of angle A? The opposite is H. And what is the hypotenuse of from angle A? It's B, this length here. So H over B, opposite over hypotenuse. And sine B, so B is this, dealing with this right angle triangle over here instead. Sine B, again, is sine is opposite over hypotenuse according to SOHCAHTOA. So the opposite is H, and the hypotenuse is lowercase a. So opposite over hypotenuse is H over A. Next line, you're asked to rearrange these two equations, the above formulas, to make H the subject. So to make H the subject here, we'd have to multiply both sides by B. So multiplying both sides by B, end up with H equals B sin A. Multiplying both sides by A on this case. So to get H by itself, we'll have to multiply both sides by A. So multiplying both sides by A makes the A cancel out here and makes an A appear here suddenly. So I've got two formulas, B sin A and A sin B. And notice that for both triangles, these are for two different triangles. Notice, what do you notice about the height for both of those triangles? And you probably noticed it's the same height. So the triangle on the left has the same height as the triangle on the right. So technically these two formulas, because they're both separate formulas for H, they must be equal to each other because it's the same height. Height H is consistent for both triangles. So as the height is the same for both right angle triangles, make two height formulas above equal to each other. So we can make the red formula, just say it's equal to the green formula because they're both the same height. Then I would suggest what you're asked to do now is divide both sides of this equation by AB, and on top of that also cancel down each fraction. Cancel down the fraction on the left if you can, wherever you can, and cancel the fraction on the right to its simplest form. So by that I mean divide B sin A by AB and divide A sin B by AB. Then you're asked to cancel down whatever you can. So on the left hand side, what we can cancel from the top and bottom, we can cancel down a B and a B. And what we can cancel down on the right hand side is an A and an A. We can't cancel down B on this side because there's no B in the numerator. So congratulations, upon doing this, what's left behind is you've actually discovered the sine rule. So sine A over A is equal to sine B over B. And if you did a similar proof, if you continued doing another proof and you did a similar thing, but this time with angle C and B, for example, or angle C and A, you'll find that they also are equal to sine C over C, lowercase c. So that's the sine rule. Notice that this version here is just the flipped version of this one. So here I've got the lengths on the top and the angles on the bottom, whereas this version down the bottom has just got the angles on the top and the lengths on the bottom. So even though you're given this version in the formula booklet, you can flip it anytime you like to make it this version. So I might make a little note of that. So what we tend to use is we use this flipped version when finding, like, so basically what do we have on the top? We have an angle. So use the flipped version, I would suggest. This is just my suggestion when finding an angle, because it's just easier to have the unknown that you're searching for on the top. It's just easier to rearrange. When you're looking for a missing length, I would say use the version that they give you in the formula booklet. When you're looking for a missing angle, I would suggest use the flipped version of this. It's just easier to solve when you've got the unknown that you're looking for on the top in the numerator. So that's the end of the proof. Now let's move on to actually applying this sine rule. All right, so now try out your formula. Remember to label your triangles A, B, and C, which is not always necessary, to be honest. You can, but it's good to practice it if you want. So label your angles A, B, and C. So if this was angle A, this side would be lowercase a. If this was angle B, this would be lowercase b. If this was angle C, this would be lowercase c. But to be honest, you can actually solve these problems without labeling the triangle. And I'll show you what I mean by that. So in using the sine rule, you know when you need to use the sine rule, I would suggest label the unknown. So the unknown is x. You know you need to use the sine rule when you're dealing with basically what we've got here. Two sides and their opposite angles. So the side and its opposite angle here, x and 53, and the side and its opposite angle here, 48.92 and 47. So when working this out, you should label the unknown that you're looking for, x, or if it's an angle, label it theta. And then upon doing that, if you've got side, opposite angle, that tells you you're using the cosine rule. As opposed to, sorry, you're using the sine rule when you've got side, opposite angle, as opposed to using the cosine rule, which is in the next lesson. Rightio, so you're asked to find the value of x. So we've identified that it's using the side rule. And the reason why is because once we'd labeled the unknown, with two angles and their opposite sides. This is the reasoning behind why we've chosen to do the sine rule. So the way you set it up is look back at your sine rule if you're not sure. So we're saying length over sine of its opposite angle equals length over the sine of its opposite angle. So just you only ever use two sides at once. You don't really bother to use three. There's no point. And plus we don't know the third side. So x over sine 33, notice that I've got them in blue because they're opposites. X over sine 53, we're looking for x, so put x on the top, put the length on the top, is equal to 8.92 over its opposite angle, sine 47. So it has to be green over green, blue over blue, for example, and these colours have to be opposite each other. And then upon doing this, it's just an easy thing. To solve for x, you just need to multiply both sides by sin 53. So multiply both sides by sin 53. The way that would look would be, I tend to write it like this, 8.92 sine 53. Notice I've just inserted this sine 53 next to the 8.92. It's a bit easier than doing sine 53 times 8.92 or writing this whole fraction times 8.92. That's also okay. Sorry, this whole fraction times sine 53, that's not wrong. For me, I just personally find it easier to plug into the calculator when it looks like this. So 8.92 sine 53, because we've multiplied both sides by sine 53. Divide by sine 47. And in your calculator, remember, use the trig button, T-R-I-G button, to make sine. And you can also use the nice fraction button to make these nice fractions appear. That's a good idea. Make sure your mode is in degrees for this particular problem, not radians. And hopefully when you if you want, feel free to pause and plug it into your calculator and then see if you get the same answer as I'm about to get. So to 3 sig figs, I would suggest write your unrounded answer first and then write your rounded answer. Just in case you make a mistake in rounding to 3 sig figs, you should get 9.74, and it's a length and the units are centimetres. Excellent, so that's done. Next example, find correct to 1 decimal place, so be aware of that. Don't do 3 sig figs, or maybe it's the same answer, you never know. The value of theta. So we're finding an angle this time in the following diagram, roughly drawn to scale. So don't use a protractor, of course. Use either the sine rule or the cosine rule, but we are going to use a sine rule this time because if you see on your sheet, you've got an angle and its opposite side and an angle and its opposite side. So remember, you have to label the thing you're looking for first, label it theta if it's not there, and then decide, is it angle opposite side, angle opposite side? Yes, it is. So we have to use the sine rule. And I would suggest, because we're searching for an angle this time, use the flip version. Use the version where the sine angle is on the top. Sine angle over side equals sine angle over side. And I tend to put the unknown first. So it's just, for me personally, easy to rearrange. Sine theta over 8.1, sine theta over 8.1 is equal to sine 113 over 14.9. So sine 113 over 14.9. To solve this, you might want to do two steps. I would suggest write out what sine theta equals first. That's my way of doing it, but you might want to go straight to the final one. You need to multiply both sides first of all by 8.1. So when writing this out, I would suggest write 8.1 sine 113 rather than sine 113 times 8.1. It's just, it looks nicer and it's kind of just easier on the calculator. 8.1 sine 113 over 14.9 still. A lot of people by accident will think that they're finished, that they would just have to plug this in the calculator. But remember, we want theta by itself instead. So theta by itself, try to think, how do you get theta by itself? We need to take the inverse sine of both sides. So taking the inverse sine of both sides means using sine minus 1, which you can find by pressing the trig button on your TI Inspire calculator. So trig button, sine minus 1, and notice it's sine minus 1 of all of this. So you use your fraction button, type in sine minus 1, then use your fraction button to make this nice fraction here, I would suggest. And to remember, it's to 1 decimal place, so write your unrounded answer first. And you might want to pause and try it out in your calculator first. The main thing is you're learning how to type it into the calculator correctly. And to 1 decimal place, you should get angle theta equals 30.0 degrees. Let's do some more examples. So find the length BC correct to 3 significant figures, so just a regular rounding. So we're using the sine rule because in the question we have angle, opposite side, angle, opposite side. That tells us we're using the sine rule. So remember, for me to do that, I had to label the unknown side x because we want BC. So label BC as x. And that means we've got angle, opposite side, angle, opposite side. So we use the sine rule as opposed to the cosine rule. And are we finding an angle or a length? Have a look. We're finding a length. So use the version where the length of the sine rule where the length is on the top. So x over sine of its opposite angle, x over sine 47, is equal to 5.6 over sine of its opposite angle. So 5.6 over sine 29. And it's a nice simple one because we just want to get x by itself now. So to get x by itself, we need to multiply both sides by sine 47. So let's show that. X equals, remember, a nice way to write it, 56 sine 47. Notice I've color-coded so you can sort of see what's been added now. We've included the sine 47 because we've multiplied both sides by sine 47. You could have, in the calculator, typed in 5.6 over sine 29 and then multiply by sine 47. I personally find it neater to write it like this and easier to type into the calculator. That's just me. Feel free to pause and try plugging it into your calculator now to see if you get the same answer as me to 3 sig figs. You should hopefully get 8.45 and think what the units are. It's a length and the units are centimeters. 3 sig figs, nice. Another example, determine the size of ACB, this little hat meaning an angle. Determine the size of ACB correct to 3 sig figs. So where is ACB? It's this angle here. So label your unknown side as unknown angle, sorry, as being theta. And in this question we have angle opposite side, angle opposite side. So that tells us it's a sine rule. Remember, the unknown has to be labelled for you to work that out. So use the, I would suggest use the version where you put the angle on top, so sine theta over opposite side, so sine theta over 15 is equal to sine 37 over 20. Make sure you always show this step, like rather than going straight to rearranging, because people can make mistakes in rearranging and you miss out on nice method marks when you do that. Again, it's a bit tricky because we've got to solve for an angle this time. So first step in rearranging, you need to multiply both sides by 15. So to show that, right, you can write. I'm being lazy here and I'm doing a shortcut. I went straight to, on top of that, also just bringing sine to the other side. But be careful, sometimes people forget that. So to begin with, you might want to write everything out. So multiply both sides by 15, makes it become 15 sine 37 over 20. And then I went straight to sine minus 1 of all of that. It's possible you can do that. You just have to try to be conscious and remember to always take the sine, the inverse sine of both sides as well as multiplying by the length. Feel free to pause, plug this into your calculator. Remember, you use a trig button to create sine minus 1 on the TI Inspire, and use the fraction button to make nice fractions here so you don't get errors due to BEDMAS. See what you get. To 3 sig figs, you get 26.8 degrees, and that's what we were asked to get. And it's an angle, so of course we need degrees. So be careful to use the right units. You don't want to lose marks for units, like that's a bit of a waste of all your work. There is another case called the ambiguous case of the sine rule. And notice this is taught through, so well, first of all, think the word ambiguous, what does it mean? It means to have two meanings. So let's notice I haven't filled that in, so I'll try to fill it in roughly for you. Ambiguous, it means to have two meanings, kind of like this diagram over here. Some people might see an old woman kind of facing this way. Some people might see a young woman facing that way and wearing a hat. So two meanings is what ambiguous means. So with the sine rule, it's possible to have an ambiguous case, where depending on what information you've been given, there might actually be two answers, two possible answers. So there could be one way of drawing the triangle and another way of drawing the triangle. So not every case of the sine rule is ambiguous, it's only sometimes. So depending, as we said, depending on how much information or what type of information is given in the question, it can be the case that it's possible to draw two triangles. Like if it's a word problem and they haven't drawn in the triangle for you, that could possibly be an ambiguous case. So there's another video, and it's on Firefly. This is a link as well, but go to Firefly and find the second video that I've posted underneath this particular video. And I would pause this one now and start to watch the other one. So again, watch the video on the ambiguous case of the sine rule on Firefly and take notes for the following. And this is where it begins. So at this point you should pause. Well, actually, to be honest, it's the end of this part of the lesson. I would stop this video and go on to the second video under sine rule, which teaches you the ambiguous case. So that's the end of this particular video. For now go on to the ambiguous case and answer the next few pages in your booklet.